All right, guys. Confidence intervals. A couple things. This uploaded a little weird, so it's a little wider than I thought, but that's fine. And then the other thing I realized here was I messed up with on the note. I messed up who's who. So if you read this here, it says the Tories, and the Tories are the Conservatives. Okay, that's a name for the Tories, and the Liberals here are at 32. The Conservatives are at 36, and I messed up here. I put the Liberals as 36, so this should be the Conservatives are at 36, and then where I had Conservatives, I'll actually put this over here anyway, this is your Liberals. So what's going on here is you have the Conservatives at 36% plus or minus 2.7%, and the Liberals at 32% plus or minus 2.7%. And where that comes from we'll talk about in a bit, but first we want to just talk about what does that mean. And what that means is we did a polling, and the Conservatives have 36% of the vote that's coming up, except we're not sure that we're right. So we're right within 2.7% up or down. So what we want to do is add 2.7% to get up to 38.7 to figure out, okay, what's the upper limit? How high can our number actually be? Conservatives are 36 plus 2.7 all the way to 38.7, or we're too high and we're off by 2.7 in the high direction, so we're going to subtract 2.7 to get 33.3 as our lower limit. So you take that margin of error and you add or subtract it from your best guess to have a range here. So our range of data is between 33.3 and 38.7. So that's what we think the Conservatives are going to get. The Liberals are at 32% plus or minus that 2.7 to get us to 34.7 or 29.3. So what the deal here is when we look at this information is the following. Look, the Liberals are, if our best guess is Conservatives are going to win 36 to 32, but we might be off by 2.7%. So if we're off by that much on the downside for the Conservatives, we can be all the way down to 33%. And if we're off on the upside for the Liberals, we can be all the way up to 34.7%. Now, is that likely that we're off like that? Probably not. But we're showing here that there is a chance that the Liberals at 34% are going to get more votes than the Conservatives at 33%. And if that happens, then the Liberals are going to win. Okay? And so when there's overlap between the ranges of data, then we can't say for certain that one is bigger than the other. Okay? If there's no overlap, so if we did a thing here, so if we go a little further here and we look at the NDP we're at what? The NDP were, I believe, at 25%. So if they're at 25%, the highest you can get will be 27.7, right? Because you're going to add that 2.7 on it, the upper limit here. So at their 27.7, they can't catch the Liberals at their lowest. Or sorry, the Conservatives at the lowest. Or the Liberals, actually. They can't catch either of these guys. The Liberals at their lowest is 29.3. The Conservatives at the lowest is 33.3. The NDP at their highest is 27.7. There's no overlap. NDP can't win. Okay? So what you have, if we were to draw this, okay, you would have that and that. There's your Liberals, upper limit, lower limit, upper limit. Sorry, Conservatives. There's Liberals, and your NDP's over here. So if there's overlap, then we can't say for certain that one is bigger than the other. This number here is bigger because there's a chance we're over here and there's a chance we're over here, and that actually this guy's bigger. But if there's no overlap, then we can say for certain that one is bigger than the other. Now, how do we get this stuff? Where does this come from? We use, this got chopped off here, but we use a couple of equations here to find the margin of error. Okay, so this one here is not the one we use too much. We don't do the sample stuff here. We don't do this and this. Okay, so I'm not going to cross them out, but I'm going to cross them out. Okay, let's focus on this. Where to the 2.7? It's the range of value that a measurement can be within. And what we do is this changes depending on how confident we want to be. If we're going to be more confident, so there's your equation, Z, the margin of error, E equals Z times the square root of P times 1 minus P over N. So we'll talk about that stuff in a second. But what you're looking at here is when you do this, if you want to be more confident, so if we want to be more confident, like 98% confident, we use a Z score that's higher, which will make our margin of error bigger. So what that means is when we do our plus or minuses, they're going to get even wider. Because if we're adding more, if this is bigger, right? If we want a higher level of confidence, then we have a higher Z score. A higher Z score goes here. It's multiplying stuff, so that'll make E bigger. So when we do the upper limit and the lower limit, we're going to be more spread out. Okay, so instead of adding 2.7 in the last case, you might add something like 3.3. Okay, so when you get that, now we're getting a much wider range of data. And in that case, maybe the NDP can win. Okay, if you want to be certain, if we're 99% sure, right, if we're super sure, then we have to put in even further weird cases. And if we're going to do that, if you're going to beat somebody, if you're going to have a higher number, you better be far enough ahead that you can't get caught. Okay? So that's where that comes from. Let's go over how to do this in a sec down below. So we have some fish. We're trying to see, are the fish actually lower? Are there less lake trout? Sorry. Are there less lake trout? Oh. Are there less lake trout? What's going on here? Still asking the same question. Are there less lake trout now than there were? So what happens is, in the first case, in 2009, we found out that 234 of 911 fish that were caught were lake trout. Okay, so that's in 2009, sorry. And then in 2012, we found out that 141 out of 689 are lake trout. So the question is, are there less lake trout? Are they going down as a percentage of fish in the largest lake in Algonquin Park? So what you do is we figure out what percent in 2009, what percent of the fish are lake trout. So 234 over 911 gets me 20.257 or 26% of all fish are lake trout. And then in 2012, it's down to 20%, 21%. So it does seem like it's lower. Okay. But can we be certain that it's lower? And for that, we have to use a margin of error. We have to find the upper limit and lower limit. We have to figure out, okay, this is our guess, but how do we know that we didn't just catch a bunch of lake trout in 2009? And how do we know that there's just not a bunch of lake trout hanging out somewhere that we're not catching now? So what we do is we take these numbers here to get the margin of error in each case. So 2009, we're using we want a 95% confidence level. So that Z score is from our table here at 1.96. So we use that as our Z score. So that goes here, 1.96 or 1.960. And then the P's that we use are based on the numbers that we got here. So that's the P for this case. That's the P for that case. You put them in this equation, and you get this, and you get that, and those are our margin of error. So that's going to get us, that is then going to get us get us towards our upper limit and lower limit. So in 2009, you're going to take the 25.7 or 2.57. You can use this as a percent or a decimal. I kind of swapped here. This is a decimal here, but now I'm going to use it as a percent. 25.7% of all fish are lake trout. I'm going to add that 2.8 from over here to get the upper limit of 28.5. And then I'm going to subtract that 2.8 to get the lower limit of 22.9. So my lake trout, amount of lake trout is somewhere in 2009 is somewhere between 22.9 and 28.5. And now the question is that going to be, all these numbers going to be bigger than the range of data in 2012? And if you do this, you realize no, because the margin of error is 3%. So when I add it to 20.5, I get an upper limit of 23.5, which is bigger than the lower limit in 2009. So when you look at this sort of thing, if you're going to do this and we go 22.9 to 28.5 is my 2009 numbers. And then here, this 20, I'm probably lower, but I can be all the way up to 23.5. So if I'm at 23.5 in 2012, there is overlap. So there is a chance that the 2012 numbers are actually bigger than bigger or equal to, I guess, than the numbers in 2009. So I cannot reasonably conclude that the number of fish are going down. And the same sort of thing happens in this example here. We do the same thing here. When you look at oh no, sorry, we're not really comparing stuff in this one. This is just, you're going to find out the ranges here. You're going to find the error, and then you're going to work your way through that for the Montreal Expos question. Okay, so same sort of thing, upper limit, lower limit. Don't worry about this question, C. Sorry, I got distracted. In C, we're solving for a different variable, but we're not going to do that. Okay, we'll just get used to finding the margin of error, adding and subtracting. Okay, if there is overlap, then you can't say the numbers are distinctly different. If there is no overlap, then you can. Okay, that's it.